Hello guys, in this tutorial I'm going to solve question number 11, paper 13 May 2022. The point P lies on a line with equation y equals mx plus c, where is m and c are positive. There is a condition, m and c are positive, so if there is any values for them negative, don't forget to reject it. A curve has equation y equals negative m over x. There is a single point P on the curve such that the straight line is a tangent. The straight line is a tangent at P. Find the coordinates of P, giving your y coordinates in terms of M. In case if we have a line and the curve, we have three cases. Maybe the line is a tangent, maybe line cut the curve at 2 points or more, or maybe the line does not cut the curve. Because now the line is a tangent, so you can solve the equation simultaneously to get the common point in between. So y equals mx plus c, and y equals negative m over x. Just equate y equals y to get an equation. Mx plus c is equal negative m over x. Multiply all by x, multiply all by x. Multiply by x is mx squared. Multiply by x will be cx. Multiply by x is negative m. Quadratic equation, write it in standard form, mx squared plus cx plus m is equal to 0. Find ABC, A, B, C. A is m, B is c, m is m. Write the discriminant, b squared minus 4ac is equal to 0 because it's a tangent. So if b, which is m squared minus 4 times m times c, which is m, is equal to 0. The discriminant is equal to 0. So after simplify, it's C. A is M, B is C, C is M, substitute in the discriminant, B squared minus 4AC. B squared now is C squared minus 4 times A, which is M, and C also is M. So C squared equals 4M squared. By taking the square root for both sides, so C equals positive or negative 2m. C is positive or negative 2m. It's written up. C and m have to be positive, so you have to take same sign. So I will use only this case, C is equal to m. When C is equal to 2m, go again to the original equation, remove C and write 2m. So the equation now is mx squared, remove c and write 2m to be 2mx plus m is equal to 0. M is constant, you can remove it. By taking m outside common, you can divide it by m because it's constant. So x squared plus 2x plus m plus 1 is equal to 0. We have a quadratic equation. We can solve it by factorization. X plus 1 and x plus 1 is equal to 0. You can write it x plus 1, the whole squared is equal to 0. So x is equal to negative 1. After finding x, you can find y from this equation or this equation. I will use the second equation, y equal minus m over x. Y is equal to minus m over x. Where is x now is negative 1, so negative is positive, so y is equal to m. As he asked, write your answer in the form of m, y in terms of m. So the point of P will be minus 1 and m. This is the first part. Find the coordinates of P. This is the coordinates of P, giving y coordinate in terms of m. The normal to the curve at P intersect the curve again at point Q. The normal to the curve, how to get the equation of normal? negative reciprocal of gradient. The equation is y minus y1 is equal to mx minus x1. This is the general equation of any straight line. But it's given the normal passing through P. P, we already have it, -1 and m. This is x1 and y1. What about the gradient? The gradient of tangent is m, written up. Y equals mx plus c. This is the equation of tangent. If the gradient of tangent m, so the equation of normal will be what? -1 over m. So the equation now is y minus m equal -1 over m, x minus will be +1. This is the equation of the line. If you get y as a subject, it will be -1 over m, x -1 over m plus m. This is the equation of the normal. The normal and the curve cut means equal again. The equation of the curve is -mx over c. Yes, is -m over x, -m over x. Again, equates again, minus m over x is equal to -1 over mx minus 1 over m plus m. How to simplify and solve this equation? You can multiply all by m, you can multiply all by x to simplify and remove the derivative by multiplying all terms by mx. The first one multiplied by mx, multiplied by mx, multiplied by mx, and multiply mx. The first one simplify, cancel x with x to be minus m squared is equal to, cancel m with m, x times x is x squared minus x squared. Cancel m with m, so the answer will be minus x. M times m is m squared multiplied by x. Quadratic equation in terms of x. Move to the other side, rearrange x squared, then plus x, then minus m squared, and minus m squared x is equal to 0. How can I solve this kind of equations? We can solve it by factorization, by grouping, because we have 4 terms. The first by taking x outside, so x plus 1. By taking minus m squared outside will be 1 plus x. So if we switch the order from the beginning will be x plus 1 is equal to 0. By taking x plus 1 common factor, you will get x minus m squared is equal to 0. Or after factorization, you can get x is equal to -1. This is the root, this is the point P. And x minus m squared is equal to 0. So x is equal to m squared. This is the x coordinate of the intersection point. And how to get y? Back to the original equation of the curve, which is minus m over x. So y is minus m over m squared. So y is equal to -1 over m. So back to this equation, y is equal minus the original one, y equals minus m over x. Y equal minus m over x. X is m squared. Simplify, your answer will be minus m. So the coordinates of the point x is m squared and y is -1 over m. I'll back to this equation again. If we face like this equation and forget factorization by grouping, and you try to solve the equation, identify A, B, C, and use quadratic formula. I will show the start how to solve this equation by using the quadratic formula. If you rearrange this equation, x squared plus x plus constant is equal to 0. This term included x, this term included x. By taking x outside will be 1 minus m squared, and x will be negative m squared, Identify A, B, C. A is equal to 1, B 1 minus m squared, and C negative m squared. Use the quadratic formula, negative b plus or minus square root of b squared minus 4ac, all divided by 2a. Take your time, substitute the values of a, b, c, simplify, you will get the same answer, which is x equals m squared. Then after finding x, you can find the value of y from the equation of the curve. This is part B. Thank you.